Alright. Good old start. A, B, C. Oh, that is okay. Okay, that is a weird condition. So, OA, OB, OC are given, and then I'm supposed to drop 3 altitudes. So x equals intersect. Okay, so, and then Evan, is there a reason why you always use that triangle? Kind of by habit, like it's just the one I use by default. I do think there's a thing to be said for using the same triangle when it's convenient, like just as a default, because then you can learn where points are physically located. Like if a point appears in the same point appears in the problem that you did in the past, it'll actually be in the same physical location. This is not that important. Like in particular, sometimes like a particular problem will just not work well with your default triangle, and like it's not a big deal. But if you can just use the same triangle always, you know, if there's a reason not to use the default triangle, I think you just use your default triangle. Not a very strong statement. Okay, so I want I to be on the Simpson line, which is like what? Why? Wow, this is hey. All right, I'll stop playing around. What does this do with the Incenter? Like what? Complex bash? I had the thought, like everything except the Incenter is fine. The Incenter is not fine. Like if I give you these random points x, y, z, there's no way I can control the Incenter. So in order to make some sort of progress, I need to figure out like, I think if we get a synthetic observation that like kind of tells us where the Incenter is, then maybe we're talking. But before that, you can't just straight complex bash this statement, I believe. Like it's outside of my abilities. Which if you were here last stream, you saw that I cannot expand more than like 20 terms without making countless mistakes. So I definitely don't want to go after this one with that thing. On the other hand though, like what is this? What do I do with an Incenter? Okay, actually, oh, hang on. They all lie on this circle with diameter DO, right? For obvious reasons. I really should draw that circle in. That is an important circle to draw. Yes, they're internally tangent because DO is a diameter and DO is a radius. Oh yeah, that's the other scary thing. Like, it's not true if I... Thank you, Soup London, for the follow. It's not true if I use X-center instead, because it's not true that the 3 X-centers and Incenter are all collinear. So something's up. I'll put it that way. I can compute all the angles, right? Like, angle XYZ is equal to... what is this? What is this angle? This angle is 90 minus b, so this angle is 2b. So this is a 2b? Wait, that can't be right. Sorry, this is, wait, what? What? This angle is twice this angle. This is 90 minus. Okay, so 180. Okay, This is like minus 2b. 180 minus 2b or something like that. So actually, you know where what all the angles of XYZ are, so this is not quite as scary as I thought. On the other hand, it still kind of scares me. Okay, okay. Can I get... Where is X? I'm trying to think. Maybe what I want to do is, rather than... Yeah. Here's an idea. Rather than complex bashing with respect to ABC, what if I use the blue circle as the unit circle? So it's like XYZ, DO, and you try to figure out where A should be. Well, A is like... You know the radius. It's like... Did Evan finish SJMO already? Yes. It went back quite quickly, actually. I don't know. I really very rarely use linearity of Harvard points, so I was surprised that I was able to do anything. Anyways, back to this. All right, I'll do the dilation. I'll do the dilation. 2 times y minus d. We'll call it y prime. What is the... Yeah, I think I should just dilate everything. So we don't have to think about the blue circle and the... Watching Aos become engulfed in flames is great. Why is this a good thing? Like, I'm the one that has to deal with it, you know? Except actually DJ is helping me. But like, don't cause more trouble for me, sheesh. Kids these days. Okay, so we're just gonna dilate the triangle so that everything's on the same unit circle. And yep, it's a thing. Dx prime. How fast does Evan type? Apparently only about 100 words per minute. Not as fast as you would expect. So I'm trying to think, like, I do these reflections, I can get... Wait, actually, I changed my mind. Can I not just complex bash this? Like, because the circle is back in the unit circle, it's back in the unit circle, right? So you can just compute the orthocenter, or incenter. I guess you have to somehow distinguish it from the other 3 X centers, but... Y prime is reflection of D over BO? Yes, because we took a dilation, a homotopy with ratio 2. I almost feel... But something feels strange about this. Something bugs me. IO is fixed, like the line IO. or the distance? Oh, I see. Okay. We can check that. This is definitely cheating, but I'm curious now. I'm sorry. I want to know. Where's the locus button? Locus J D. Ah, okay. That's just because the formula for OI squared. R minus... I mean, in that case, what it's asserting is that the in radius is also fixed, right? Like the in radius of this circle as I vary. Yeah, which is a stronger assertion, but also... like, what the heck? Oh wait, yeah, the angles are fixed. Okay, good point. Yes, because the angles don't depend on D. Okay, yes. So that is where it should rotate. Good point. All right, let me actually draw the Simpson line. So H is going to be the triangle center ABC4, and the assertion is that line JH is doing something nice. There's a Simpson line. I want it to. I want this to be Simpson line, or not the. I want the reflection of D across the sky to be there. That's informative. It's actually... So that's the second intersection is the orthocenter. Interesting. Okay, so it's actually radius OH. What does KoMaL stand for? I don't know what it stands for. I know it's a Hungarian math journal, which is actually quite nice. There's a lot of really good problems in there, actually. Because like US students don't read it, I often use it when I like want to look for practice test problems that they haven't seen before. I guess now I said that, so now well, there's a lot of KoMaL, so I don't think they'll give away very much. Yeah, I shouldn't have said that. RIP! Well, okay. Okay, so what's going on? Oh, okay, I know what's going on. Because this triangle, there's, we're just rotating the triangle, right? And there's a certain point where this triangle will exactly coincide with, wait, no, not here. Where is it? Damn it. I know it's somewhere. No. No. Wait, maybe I'm wrong. Sorry. Basically, what I was going to say is that because the reason that OJ is OH is because this triangle is similar to the triangle you get when you take the reflections of H across the opposite sides. And, yeah. That triangle has incenter H. To do on Evan's test. Why would you cheat on like an Otis practice exam? Like, never mind. It's literally a practice exam. Like, yeah, but my point is, like, the angles aren't just random. They actually are, they're the same angles as the reflections of H across the sides. And so, you know, there's a reflection applied, but that's okay. So we get for free that OJ is equal to OH, just period. That's actually very surprising. Wait, this is so clean. It's, okay. So OJ was fixed because the shape of the triangle was fixed. OJ fixed. Since triangle is fixed shape, OJ equals OH because that shape is oppositely similar to the triangle formed by reflecting H across sides. Which means what? And that triangle is Incenter H. So that's why H is involved. Yeah, point is the angle is the ortho triangle. So at this point we know the incenter lies on this very special circle, and now I just want to get on the Simpson line. What does it mean to be on the Simpson line? This is where I have to actually think a little bit about the direction, right, that its things are in. What's Simpson, Wallace? It's just it's the Simpson. Just like don't waste your time like getting in trouble with AOPs, right? Like I don't know. Okay, so I definitely could complex bash the problem now, because what you would do is x prime, y prime, z prime is oppositely similar to that orthic triangle, and then you can compute the similarity explicitly. That will give you the coordinates of j, and then you can verify coincides with the Simpson line. It looks so clean. I almost feel strange not doing it, because I don't think you use the addition operation. I think you don't use the addition operation, like if I complex bash this. Is midpoint DH on the Simpson line? Yes. Yes. Not by definition, but that is a property of the Simpson line. So yeah, that's why this is... I want this purple guy to be the dilation of the Simpson line, by which I mean I need the reflection of D across each of the sides to lie on here, I think is necessary and sufficient. I can just complex match it. Should I? Should I just do it? We can use moving... No! Don't use moving points! No, if your objective function is to just solve the problem now, you should use complex numbers. You should not waste your time using moving points, because that's much easier to get wrong. Like, if you use complex numbers, there's no chance you get it wrong, and it will take, like, probably less time. Like, this is... Yeah! Don't use moving points! No! Don't use moving points! Also, is my poll software just dead? Is my internet dead? Why can't I... No! Where's my poll software? How am I supposed to get a vote now? Let's see. Includes a moving point Otis unit. Yeah, I really think the moving points unit is like a mistake. Okay, okay, we're just gonna use complex. Screw it. We're just doing it. Okay, so, x prime is d squared over a. Y prime, z prime, similar. And the triangle with vertices minus bc over a, minus a over b, minus ab over c has orthocenter a plus b plus c. So that's, that happens. Now, so to get from minus bc over a to d squared over a, what I do is the map is called u conjugate, and then you multiply by d squared abc. Wait, that seems really fat. Really? Hang on, that's not right. It should be a conjugation and then multiplication by some factor. It's abc over d squared. No. D squared over z. Sorry, not conjugate. D squared a over bc. Oh, that's a mistake. This should be a squared over d. Ah. So I can't even do one-term complex batches correctly. Okay, so d squared over z, and then I multiply by abc and divide by d. So it's just abc over z. This is the map. This is, because everything is on the unit circle, this is actually an opposite similarity. I could write z bar instead of... Actually, it's more clear if I write z bar, actually. This is the map. It's the opposite similarity that will drag one place to the other. So under this map, what do I get? The incenter j has coordinates, what is it? bc over d plus cd over a. Oh man, I lied. I have to use addition. ab plus bc over plus ca over d is what it is. Okay, so that's j, and I want to show that j is on the Simpson line of d, which it is, because... Why is it? How do I check this? Haven't been invited to Discord yet? Wait, if you're an Otis student that's not on this Discord, please send me an email. Oh, I see. There might have been... Oh, right. I added... Okay, yes. Yeah, I'll do that later today. What's a close form of the Simpson line? I don't remember. I just remember how you do the reflection. Frick. I only know that a plus b plus c over 2 is in this case where something we want. Whatever, we'll just do the reflection, it's okay. A plus b minus ab over d. Okay. So I want this collinear, with like this, and it's on the wiki. Oh, jeez. Okay, so, wow, that is weird coloring. Yeah. So AB... I think this is what the lighting actually looks like in, like, before the webcam does. I've learned that apparently webcams just automatically, like, do some things to the color, and it's... whatever. Play with a hue shift. Whatever. Okay. I'm supposed to check these are collinear. I keep putting it off. Are we complexing? Yes. I feel like I should know what the equation of the Simpson line is, and I don't, which makes me sad. Okay, okay, everyone, buckle up. We're just gonna do it. We're just gonna do it. We'll put aside our morals and we will just do the calculation. All right, let's get this over with. The determinant I want to evaluate is AB plus BC plus CA over D. Its conjugate and 1. Why? Oh, my compiler crashed because I left out a brace. The thing that bothers me about this is normally when I do this calculation, what you're supposed to do is you shift it by like A plus B plus C. Did I drop a minus sign in my map? You are correct. There is minus sign missing. Yes, yes, thanks, thanks. Like I literally can't do anything right these days. I'm so bad at this now that it's like embarrassing. Okay, so 1 over A plus 1 over dA plus B minus AB over D. So we're just gonna do it. D A plus B minus D D 1 D B AB 1 and let's use like C instead of. Okay, so if I haven't completely messed up yet, this determinant is supposed to equal 0. And how do I check this? Well, I can subtract row 3 from row 2. Yeah, that sounds good. So let's start doing that. And oh no, I actually don't really want to subtract. Yeah, let's get rid of all the fractions first. I think that's a good place to start. So there's a factor of D that just goes away from the first column. And for the others, I guess I multiply by ABC, right? So this becomes C, A plus B minus D. This becomes B, A plus C minus D. The teacher also asks. Oh, the good old days. I miss the Taiwan. You know, if I wasn't in the freaking US, I had this like great opportunity to go and help train the Taiwan team, because Taiwan, unlike the US, is doing really well with the coronavirus. But I'm from the US, so you know, if I go to Taiwan, they just quarantine me for like a couple of weeks, and well, maybe that's okay. Maybe I should have just done it anyways. Is there anything good to subtract? Can I just subtract? Yeah, let's just subtract. Okay, we'll subtract. I really hoped I didn't have to use the addition operation, but I think I have to use addition. Okay, so A. The BC's cancel, so it's like A minus D, C minus B. So it's literally the same term twice. Right? Right. If I subtract. Why did I feel 2015 USMO 2 was hard? I don't know. You're not alone. You should see the scores on that problem. Okay, so. Janice, oh yeah, welcome to the stream. Don't worry, this is like a nice bash. For whatever definition of nice you endorse. Okay, so we're gonna use minors. This just works, right? There's no way this doesn't work. So, minus D A plus B plus C, minus B A plus C minus D, plus, minus AB plus BC plus CA. Shoot, I flipped the order. Try again. BA plus C minus D plus DA plus B plus C, and then minus AB plus CC plus CA. Minus D, A plus C, minus AC. Yeah, I don't need it to care. Okay, well I just dropped the constant factor. What is my favorite Otis combo unit? Definitely equality. Equality was almost like the first combo unit. Like it was the first one where I was like, wow, I really have something good for combo. AC, BB, BD, BD. Yep, okay, equals 0, we're done. We're done. Done. Alright. Yeah. Yeah. This is the first time a complex bash went well on stream. That's because when you look at the complex bash, like, oh, actually there are 12 terms. Okay, so it's like a little longer than the last one. But like, you know, the Incenter was literally this. Like, it's like, this has to be easy. Like, even I can do it. I now know the, oh yeah, that's great. Now I know the Simpson line is the line through like this guy and the ortho center, I guess, once you dilate back.